Surface area is the area of the outside of a three-dimensional shape. A common mistake for students is to actually miss one of the sides when they're trying to find the surface area. A good idea when doing surface area is to imagine unfolding the shape into a flat net. So looking at this three-dimensional triangular prism at the top, you can see that if I unfold it, it would have two triangular ends and three rectangular, or it looks like they're square in this case, sides. You need to find the surface area of each of those sides and ends. A prism with a trapezium on the end, like this one here, unfolds to have this many sides as shown next to it. The two ends and the four other sides. The dodecahedron that I'm showing over here on the right is a shape that has 12 sides that are all pentagons, and you can see them here unfolded. If I knew the area of one of those, all I would need to do is multiply the answer by 12 to get the total surface area. But we won't be looking at those, we'll be only looking at prisms. A prism is a three-dimensional shape that has the same shape on each end. So this end here is a triangle, and the other end, which you can't see, is also a triangle, these two here. The rest of the sides are rectangles. If I cut a prism through the middle, I'll get triangular ends still. So the triangular shape is consistent all the way through, and any cross-section you do through the prism, where the line is, will be triangular as well. In this example, we're going to be looking at finding the surface area of this prism. It's a rectangular prism because it has rectangles, or a rectangle, on the end. Now it says up here that the cubes are 1 centimetre wide, so if I've got 6 cubes on the end, that means I've got the area of the end is equal to 6 square centimetres, or centimetres squared. Now, because it's a prism, there will be two of those ends. One here and one at the back here that you can't see. So when I get my answer, I'm going to double that. So the area of both ends will be 6 and 6 is 12. Looking at the side, you can see that there are actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or 2 times 5 is 10. So the area of the sides is equal to 10 centimetres squared. The top has 1, 2, 3 by 1, 2, 3, 4, 5. 3 5s are 15. So the top is equal to 15 square centimetres. For a prism like this, a rectangular prism, there are two of each of those. There's a top and a bottom, which will be 15 square centimetres. There is a front and a back, the two sides, which are 10 each, and there's also the two ends, which are 6. So that means that the total area is going to be equal to 6 by 2 plus 10 by 2 plus 15 by 2. So that's 12, 20, 32, and 30, 62 centimetres squared. For this next example, what we've got is a triangular prism. Now that means it's going to have two triangles, one on each end, as shown in this net, and 3 rectangular sides, which in this case are squares because these little lines mean that everything that's got a line on it is the same length, so they're all 2. So let's start off with the easy part. That's the 3 sides. So the area of one side, for example that one, is equal to length by width, which is equal to 2 by 2, which is equal to 4 metres squared. And there are 3 of those. The two ends, however, like this, are 2, 2 and 2. Now none of those numbers there are height. For the triangle, I need area equals half base times height. So we'll have to calculate the height. What we're going to use is Pythagoras. So here is a triangle that cuts that end into two, makes a new triangle, and we need to know what x is here because that's the height. So using Pythagoras' rule, once we've worked that out, we can then substitute it back in here for h. So let's do that. So c squared equals a squared plus b squared. C is 2 because it's the hypotenuse, and the hypotenuse is the longest side opposite the right angle. So 2 squared equals x squared plus 1 squared. Now I put 1, and a common trap would be to put 2 because remember we've cut this 2 in half here, so it's only going to be 1 from there to there. Right, now I need to solve for x. So I've got 4 equals x squared plus 1. Subtract 1 from both sides so I can get rid of the one that's over here because they make 0. X squared equals 3. Square root both sides because I'm trying to get x by itself. And x will be equal to the square root of 3, which is 1.73. So now I can substitute back into the area formula the value of the height being 1.73. Area equals half base, the base is 2, and the height is 1.73. And that equals 1.73. So the total area for the surface area for this particular prism is going to be equal 2 times those 1.73s, which is the two ends, plus 3 times 4 for the 3 rectangular or 3 square sides. And that equals 15.5 metres squared. So here's another example. There's a bit of a trap in this one. Notice that this measurement here is in centimetres and the other two are in millimetres. We need to make them the same. So if I've got 1 centimetre and I want to change it to millimetres, I need to move the decimal point one place to the right or multiply by 10, and I'll get 10 point millimetres. So that means if I'm doing the area for this one here, I've actually got 3 sides, but they're not all the same rectangle. So if I draw the net or expand out the shape by folding it out, I'll get something like this. So I've got the two ends, and I've got this bottom or top, which is this side, and these other two are these two sloping sides, one here and one on the other side that goes along there. Now those two are not the same as this one. Let's have a look at the numbers. So for the middle rectangle, it's got a width of 10 millimetres and a length of 35. The other two rectangles don't have that same 10 width because their width is here and here. Those two there are not the same as this 1 centimetre or 10 millimetres across there. We're going to have to work this out. To do that, I'm going to make a triangle like this, where it's 10 there and the height is 13. Let's split it in half so we can use Pythagoras again. If I do that, then this little side here will be 5 and that side will be 13, and the one we don't know, x, is the hypotenuse. So let's work that out. X squared equals 5 squared plus 13 squared, so that's using c squared equals a squared plus b squared. X squared will be 25 plus 169, which will equal 194. And I need to do square root of both sides for that to find x. Square root. So x will be the square root of 194, which is 13.9. So these sides here are 13.9. So that's the trap with this question here. Even though it's got 3 rectangular sides, they're not all the same. So what we'll need to do now is work out the area of the two ends. So let's look at this area up here. The area of that one is going to be equal to half base times height, which is equal to a half, 13 times 10, which is 130 divided by 265. This side here, this side here is going to be 35 multiplied by 13.9, and this other side over here will be the same because it's got the same width and length. And the middle rectangle, length by width, will be 10 by 35, 350. So we need to add all those up together. So we've got two of the 65s. So the total area is going to be equal to 2 times 65, because that's the two ends, plus 350 for the middle rectangle, plus 486.5 multiplied by 2. And all of that ends up being 1,453 millimetres squared. If I change that to centimetres squared, I'd have 14.53 centimetres squared. Remembering, of course, that when you move the decimal point for millimetres squared to centimetres squared, you have to do twice as many because they're area. So 10 millimetres in a centimetre, but 100 millimetres squared in a centimetre squared.